All right, greetings everyone. Welcome to the second part of the video for section 6.4. Continuing on with our study of solving trigonometric equations. So let's take a look at this one, which is kind of a step beyond what we had done previously. So we're asked to solve root 2 times tangent of theta plus root 2 equals 2 root 2. And here we're asked to find all solutions. All right, so this is going to involve that plus 2 pi k thing. All right, well, first thing we need to do is think about if this equation, instead of being what it is, was something like square root of 2 times x plus square root of 2 equals 2 root 2. What would we be trying to do in that case? Well, we'd be trying to isolate the x, right? Isolate the variable. So we're going to do a similar thing here. However, we're going to start by trying to isolate the term with the variable. So our variable in this case is the theta. I'm going to isolate the term with it, which is the tangent of theta. Also, I know there are roots involved here. However, we can still approach this the way that we approach any other type of algebra problem like this. We'll start by subtracting the thing that's being added. So we'll subtract root 2 from both sides of the equal sign. When we do that, we'll end up with square root of 2 times tangent of theta equals, and again, we don't have any more root 2's there because that has canceled. And then we have 2 root 2 minus root 2. We'll notice that this minus root 2, we could put a 1 out in front, so this is like 1 root 2. So 2 root 2 minus 1 root 2. Well, that's just going to give us 1 root 2, or actually just square root of 2. Okay. And then to finish isolating the tangent term here, we'll divide by the thing being multiplied by it. So divide by square root of 2. So these will cancel now. And we're left with just tangent of theta equals, and if we have square root of 2 divided by square root of 2, that will give us positive 1. Okay. And now this is very similar to the problem we did before. And we just have to think about values of theta, so angles on the unit circle where the tangent could be equal to 1. And I know we don't have tangent values on the unit circle, so this might be a little more difficult to recall quickly. However, also recall that tangent of theta is equal to sine of theta over cosine of theta. And if we have that value is equal to 1, well, what that must mean is that our sine of theta and our cosine of theta are the same, right? Because if we take something and divide it by itself, we get 1. So we have to think about where on the unit circle are there angles that have sine and cosine equal to the same thing? Well, one place where I know that happens is at pi over 4. Because sine of pi over 4 is root 2 over 2, and cosine of pi over 4 is also root 2 over 2. So that's in the first quadrant. I believe we also have this in the third quadrant with 5 pi over 4, right? Because sine of 5 pi over 4 is negative root 2 over 2, and cosine of 5 pi over 4 is also negative root 2 over 2. And then here, because we're asked to find all solutions, as we saw before, we can show that by adding 2 pi k to each of these, because that tells us if we keep spinning around the circle, either forwards or backwards, we'll continue to get solutions. So here would be our answer. Theta equals pi over 4 plus 2 pi k, and 5 pi over 4 plus 2 pi k. All right. Cool. Now, one more thing about this. So I'm going to draw a picture here of these angles. So we saw that we have an answer here at pi over 4, which is in the first quadrant. And 5 pi over 4, that's a terrible line. I'll try better. There we go. Which is down here, so 5 pi over 4 here in the third quadrant. And we said that we could add 2 pi k to get more solutions because, for example, if we start at pi over 4, if we do full rotations, forwards and backwards from there, we continue to get more solutions. However, notice in the unit circle that pi over 4 and 5 pi over 4 are reflections of one another, or kind of reflected across the origin from one another. And moreover, they're a distance of pi apart. So it looks like we can start at pi over 4, go pi units around the unit circle, end up at 5 pi over 4. If we continue on pi units from there, we'll get back to pi over 4. And we could keep going this way forever and ever, both forwards and backwards, and ending up at solutions each time. And so what that tells us is, in this case, there's actually a more concise way to write our answer. So instead of having two separate expressions, with pi over 4 and 5 pi over 4, we could write this as pi over 4 plus, and again, we saw that if we went pi radians, so half a rotation, from pi over 4 to 5 pi over 4, we got a solution. So in this case, we could do pi over 4 plus pi k. Okay, and that would actually be the same as the answer we got before. Now, that's not to say our first answer is wrong, and in fact, I would accept that first answer as an answer, but the second one is a more concise way to write it. Okay? All right. Let's take a look at this one now. So here we're asked to solve sine of 3 theta equals 1/2 for all solutions. And this looks kind of similar to a problem we've already done where we had to solve, I believe it was sine of theta equals 1/2 for all solutions. We've done that already. And in fact, I'm going to write off to the side here the answers we got for that, which in this case, I believe were pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. But that's not what we have in this case, right? We don't have sine of theta equals 1/2. We have sine of 3 theta equals 1/2. So what we're going to do to start here is try to actually make this more like the problem I was just looking at, have just sine of theta equals something. And the way we can do that is by choosing a value I'm going to call u, a variable, that's going to be equal to what's inside the sine value. Okay, so I'm going to say u equals 3 theta. And since these two things are the same, that means I can actually substitute u in the place of that 3 theta. And so what that'll give us now is, instead of sine of 3 theta equals 1/2, it'll just be sine of u equals 1/2. Which, even though this is a different variable now, it's a u instead of a theta like we had before, you can imagine that our answers would be the same, right? Finding all solutions, we'd get u equals pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k, since the sine of any angles that we get from those expressions is equal to 1/2. Okay? But notice that these are values for u, right? And I could even also write u equals here. And we weren't looking for values of u, though. We were looking for values of theta. And we have from up here that u equals 3 theta. So what we can do is substitute this back in. So instead of writing u equals, we could write 3 theta equals each of the things we have here. So pi over 6 plus 2 pi k, or 3 theta equals 5 pi over 6 plus 2 pi k. And then again, we're trying to find theta, so we need to isolate the theta in each case, which means we'll divide by 3. When we do that, we need to divide everything over here on the right-hand side by 3. Do a similar thing here. Okay, so the 3's will cancel out, so now we have theta equals, do a little fraction division here. So we have, first of all, pi over 6 divided by 3. We can make that a 3 over 1. If we do our fraction division now, we'd have pi over 6. Instead of dividing, we make it multiply. Instead of 3 over 1, it'll become 1 over 3. And we multiply, we end up with pi over 18. This would be pi over 18. Plus, we can leave the other part as 2 pi k over 3. So that answer has now become theta equals pi over 18 plus 2 pi k over 3. And I'm going to go through all the steps on the second one, but you can check that we would get 5 pi over 18 plus 2 pi k over 3. Okay. All right. Well, this method we used here where we said u was equal to the thing inside the trig function. This is a technique known as u substitution. And we'll use it more in this class, but it will come up for those of you that move on to calculus, and in particular in calculus 2. This is a really important technique, so it'd be a good idea to get in the practice of using it now. And notice again, we solve for u first, and then once we have values for u, we put back in the thing in terms of theta and then do our division. That's an important step that a lot of people miss. Okay, that's it for now. Thank you for watching.